and good afternoon. This is the host Aishwarya welcoming you in the program in Access India. Today I am in Nainital to explore ARIES, that is Aryabhatta Research Institute of Observational Sciences. It is situated at Monera Peak in Nainital and it has a strength of 50 to 60 students. It got established in 2004 and it focuses on astronomy and data sciences. So let's get inside and explore it.
I am Dipankar Banerjee, currently the director of Aryabhatta Research Institute of Observational Sciences, in short ARIES.
So when did this institution came into existence?
So this institution has a long history. In 1950s, this was called UP State Observatory, and at Nainital, it actually moved from Varanasi, and until 2004, this was called as UP State Observatory. But after the birth of state of Uttarakhand, Department of Science and Technology, Government of India took over this observatory and ARIES was born. So Aryabhatta Research Institute came through existence in 2004. So the primary focus of this institute is in the research of astronomy and astrophysics and also in atmospheric sciences. So this institute hosts currently the largest optical and infrared telescope from India. So these facilities, namely the 3.6 meter Devasthal optical telescope and the 4 meter liquid mirror telescope, these are national and international facilities.
Here at my back, you can see the glass building that is the auditorium of the institute. So let's get inside and explore it. Here when I come just 10 to 15 steps down from the institution, I can see very beautiful hostel made for students. And not just to stay, but they have net and other sports activities also available so that they can engage in sports as well rather than just staying here. So let's explore the hostels. Here I am in the optical lab with Mr. Jayshrikar. So let's know about the lab from him. So please brief the lab.
Yeah, so this is the clean room facility of this lab. Here is a laminar flow. This is the optical bench, which is a vibration isolation optical bench. And here we have provided the electrostatic mat. So whenever we do some kind of experiments like opening the CCD chip, at that time we use this facility.
So now here I am at the 1 meter Sampurnan telescope lab and I have Mr. Saurav to brief about. Please tell.
Yeah, welcome to 1 meter telescope facility of ARIES. So this is one of the oldest telescope we have at ARIES. This telescope was installed in 1972. So this is 52 years old telescope. And this telescope, 1 meter if you say, 1 meter is the diameter of the primary mirror. So this is 1 meter. And this is the focal plane where we put various instruments like CCDs or spectrograph and other things. And this telescope was installed by a German company called Zina. And since then, it is still used for like science observation of celestial objects. Many PhD students have used this facility for their thesis. And this is the control panel to control this telescope. This is also very old system. Nowadays, you can control the telescope using computer and giving commands, but this is analog system. All the drives and everything is here. So you move the telescope manually in different axes and then you track the celestial objects and then control. To start the observation, first you have to open the dome of this telescope, which is this. So this is the slit of the telescope. So through this slit you can observe. So we are opening the slit. And then depending on the position of a star in the sky, we put their coordinate using this RA and DAC, they are the coordinates. So we move this telescope through these buttons. So we can move the telescope And then once the telescope is moved toward the star, then you can move the dome towards that direction. So you move the dome so that the slit of this dome can align with the telescope, and then you can do observations. Most of the observers or PhD students use this telescope for their PhD thesis or other research work. So there are different kind of science you can do. So usually most of the time there is a CCD which is mounted on the focal plane of this telescope, and you keep this dome completely dark and cool so that there is no ambient temperature difference, and then you come up into this observing room, and in this room you can control all the instruments which are there in the focal plane. So for example, there is a CCD, so you can have different filters, you can move those filters, and you can do imaging in different bands.
This is now the one lab for the atmospheric science, and we deal with the research on air quality and climate change study. And we are doing the observation of different trace gases and aerosols. So this is the one lab where we have the instrument for the surface observation of trace gases like ozone, CO, NOx, and we also have the instrument for the observation of the different aerosols component like black carbon, elemental carbon, organic carbon. So here you can see some of the instruments. They are measuring the ambient amount of ozone, and this carbon monoxide, which is around, you can say, 197 ppb or 200. So these are the almost, you can see, the clean air we are seeing here. The NO level, they are in the PPT level, around 50 ppt.
We have measurements of elemental carbon, organic carbon and black carbon from athylometer and ECOC analyzers. So these are basically important part of particulate matter, and they affect our health and are also responsible for climate change. So here we measure the ambient measurements which are used for the purpose of study, monitoring, developing emissions inventory, and henceforth help us reduce air pollution in general later.
So here I am at the ST radar lab, and the purpose of this lab is to measure wind profile and temperature profile of up to 24 kilometers. So let's get inside and check it out. Now here I am at the Science Center for Visitors. Ma'am, please brief us about the center. What all things are shown to the visitors and what all are there? Please brief.
We have a science center at ARIES. We have visits here, day visit as well as the night visit. So in day visit, we show a planetarium and a video show. In the night session, we have these telescopes here, through which we use it for the stargazing basically. It's a 8-inch telescope, which means its primary mirror is of 8 inch, and it's a 10-inch telescope. And similarly, we have other telescopes of 14 inch, 16 inch. Here are some science models with me. So this is a series spectroscope. So what you have to do, as it says, close to eye, so you have to keep it on the eye, and from here light enters, and what you can see is a spectrum. This is a star wheel. So what it can it can tell you the current sky map of your location or at that particular time or month. Here you can see are the months, the dates of the months, and this is the time from midnight to noon. So what you can do is set your month, date and time, and then you can see here is the map of the current sky. Coming to this one, which is an interesting one, it's called Foucault pendulum. So it was invented by a scientist, Foucault. At that time, there was a debate of if Earth is a flat or it's a sphere. Okay, so this model explained that Earth is a sphere.